Greetings and welcome to lecture 8.3. We're going to start discussing about surface area. What surface area is you have a three-dimensional object, and the surface area would be the area, the sum of the area of each side of the object. For example, a rectangular solid has a front, a back, a top, a bottom, and two sides. If it was a cube, then it would be very easy to figure out the area because every side has the same area. But with a rectangular solid, the back and the front have the same dimensions, the side and the side have the same dimension, and the top and the bottom have the same dimension, but it doesn't mean that all six sides have the same dimension. So to find surface area of our box, we're going to sum the areas of each of the six surfaces. In other words, find the area of the side, the front, the back, the top, the bottom, and add them all up. But that's kind of a lot of work. So we're going to build a formula from what we know to make it a little bit easier for us. So first, the side, when we look at it, the area is a rectangle. So it's just going to be the length times the width. But in this terms, the length is the length and the width is the height. So it's L times W. So the side is L times W. Side is L times W. The front, let's look at the picture, is going to be the width times the height. So the width, or the height times the width times the height. So the front and the back have height times width. The top and the bottom, let's look at that. The top has the length of the length, but has the width of the width dimension. So it's LW, and the bottom is LW. Let's put that all together. Combine like terms. We have 2LH plus 2HW plus 2L times W. That's going to be our formula that we use. Let's put it in action. Let's find the surface area of this box, given that the width is 3 inches, the length is 4 inches, and the height is 5 inches. Again, if this was a cube, this would be very easy. It would be length times length. It would be side times side because they're all going to be squares times 6 because all 6 sides are equal. But this one is not equal. The dimensions are different. So using our formula, I'm going to say 2 length times height, the length is 4, the height is 5, times 2 times the height times the width, so it's 2 times 5 inches times 3 inches, plus 2 times the length times the height, or length times the width, so 4 inches times 3 inches. Becomes 2 times 4 times 5 is 20, inch times inch is in square. 2 times 5 inches times 3 inches is 15 inches squared. 4 times 3 is 12 inches. 4 inches times 3 inches is 12 inches squared. So I get 40 inch squared plus 30 inches squared plus 24 inch squared, leaving me with 94 inches squared would be the surface area of the box. In other words, it takes 94 square inches of material to fold this up into a box. So it's not filling the box, it is actually creating the box, would take 94 inches squared of material. Let's move on to our next geometric shape, the surface area of a cylinder. Now, let me show you what a cylinder is. So here's a piece of paper, and I'm going to curl it up on itself, and this is a cylinder, right? It's a circle shape. If I can get it to stand up like a circle, there we go. It has a flat surface, and it's a round cylinder. Now, here's the cool part about a cylinder. If I actually cut a line down the cylinder and open it up, it becomes a rectangle. So keep that in mind, that it's actually a curved rectangle. It's curved on itself rectangle. So knowing that, I know in essence, the height of the cylinder, if I unfolded it, would be the width of my rectangle. Now, how do I figure out the length of my rectangle? Well, the cylinder creates a circle on the bottom. So if I find out what my circumference of that circle is, that's going to be the length of my rectangle. So in essence, it's the area of a rectangle. But we use different letters because we are talking about a cylinder. Now that is a cylinder. Remember, here's my clever cylinder with nothing at the bottom and nothing at the top. It's open. It's called open at both ends. So if it's opened at both ends, then if we unfolded it, it would just be a rectangle with the length being the circumference of a circle, that's 2 pi r, and the width being the height of the cylinder is h. So it's 2 pi r times h. Now keep that in mind. We have another cylinder where it's closed at the end, meaning right up here is a solid. That is solid, but the top part is open. Well, the solid is a circle, and we know how to calculate an area of a circle. So you take the area of the tall part of the cylinder, that's 2 pi r h, and you add the area of the circle that's on the bottom, which is pi r squared. So your formula of the surface area of a cylinder with the one end closed will be 2 pi r h plus pi r squared. What about closed on both ends? Well, that just means we have one circle on the bottom and one circle on top. So in essence, 2 of the pi r squareds. So it's 2 pi r h, that takes care of the tall part of the cylinder, times 2 circles, 2 pi r squared. So again, I just want to show you, maybe it will make more sense, is if I have a cylinder, I can fold my paper into a cylinder here. If I have a cylinder and the edges, you'll see that it's nice and round at one end, well, kind of round if I was to show you, round and round, but they're both open. And again, if I cut it along the height and I open it up and lay it flat, it becomes a rectangle, where the length was that circumference of the circle and the height of the cylinder is the width of my rectangle. So circumference of the circle, pi r squared, and the height, which is the width, becomes the surface area of the cylinder. With one open cylinder, we're going to add a circle bottom. So that's the area of the circle is pi r squared. So we take what we learned in our cylinder, add the circle to it. So surface area equals pi r squared h plus pi r squared. And then closed at both ends, we just take what we know about the closed at one end, and we add a circle at the top with the radius of r, which is pi r squared. So again, surface area, 2 pi r h plus pi r squared will give us the 2 pi r h plus 2 pi r squared. It's going to take a little bit of working with these to remember which formula you use for each type of cylinder. Let's consider an example of a drinking straw, which has a radius of 0.125 inches and the length of 6 inches. Well, I don't have a drinking straw, but it's just recently Halloween, and I do have a red vine. So, hold on. Let me make it in straw. Alright, so now, I know you can't really see it, but there is a hole that goes all the way through to the other side. And so we'll pretend this is my drinking straw. So if I was to, in essence, how much material does it take to make this straw? So if I was to cut this lengthwise down and laid it open, how much square area would that be? So my straw is a cylinder with opens at both top and bottom. So my formula for my surface area is 2 pi r h. 2 pi times 0.125 inches times 6 inches will be approximately 2 times 3.14 times 1.25 times 6, giving me approximately 4.71 inches squared. Sounds like a lot. But if you take a straw and you cut it open, you lay it flat as best you can, and if that becomes a rectangle, you'd see it's quite a bit of material. Let's talk about our last geometric shape, which is a sphere. Think about a ball or a globe, or even the earth is a sphere. Not a perfect sphere, but it is a sphere. We're not going to come up with the formula, I'm just going to tell you what it is. The surface area of a sphere is 4 pi times the radius squared. So 4 pi r squared. We're going to throw everything but the kitchen sink at this problem to try and solve the surface area. And I'll show you the figure in a moment, but think about what the figure is before I reveal it. The figure below is composed of a right circular cylinder with a half a sphere on top. A half a sphere is called a hemisphere. We're going to find the surface area of the figure, assuming that it's closed on the bottom. So we have a cylinder closed at one end, and then I have a half a sphere, so a hemisphere. And if I add those two together, the surface area of both of those together, I'll get my solution. So this is what it will look like. Cylinder with a closed bottom and a half a sphere on top. Okay. So the surface area of a cylinder closed at one end, we're just going to use our formula, 2 pi rh plus pi r squared. A hemisphere is half of a sphere, so I'm going to multiply 1/2 times the formula for a sphere, the surface area of a sphere, which is 4 pi r squared. That will give me the surface area of our object to be 2 pi rh plus pi r squared from the cylinder plus 2 pi r squared. Now here's the thing. I'm going to try and make this problem as simple as possible. So I'm going to treat pi as a variable like it was x. Okay? I'm going to do all the numerical amounts, and since everything includes pi, it's going to be like terms. I'm going to combine all of those, add those all together, and then the last step I'll multiply by 3.14. I just find that it's easier and I'm not working with big numbers. And since everybody has pi, I can do the multiplication of pi at the very end. Here's what I mean. 2 times 5 times 10 is 200 pi. Treat it like an x. 5 squared is 25 pi. 2 times 5 squared is 50 pi. But these are like terms. 100 pi plus 25 pi plus 50 pi is 175 pi, and I just tacked on the dimensions would be inches squared. Pi we're going to approximate as 3.14. So the final end, I'm going to do that multiplication. 175 times 3.14 inches squared gives me approximately, very close, 549.5 inches squared. Now, I could have multiplied each step by 3.14, but then my numbers would be very complex versus just treating pi as a variable until the very end. Now, going through the video, knowing what you know, here's your class problem for this video. The radius of the planet Mars is 2,106 miles. What would the surface area be of Mars? Consider Mars as a sphere, not a perfect sphere, but we'll treat it as a sphere with the radius of 2,106 miles. So that's your class problem to turn in the next class session. So until then, be seeing you.